I'm currently learning about the binary system. Did you know that all of the computers in your house function like this?
But like millions and billions of times.
The binary system consists of ones and zeros. Each 1 or 0 is equal to 1 bit. A bit is basically the shortened form of binary digit. Now, you might be wondering, why do computers use ones and zeros and not our decimal system? Great question. The decimal system we use is made up of 10 digits, 0 through 9. If a computer has to switch between 10 different combinations, then it would be working too hard, which means
Bits are the smallest unit of data in computing. Adding more bits can create more common data units such as megabytes, gigabytes, terabytes, and whatever this is. Back to the light switch example. 1 would mean the switch is on and 0 would mean the switch is off. In the computer's hardware, there are billions of transistors that turn on and off depending on which number it receives.
Now, someone might say, if it happens billions of times, then wouldn't the computer go?
Yes, but actually no. You see, there is a fan in the computer's hardware that cools things down, like this.
The binary system was first researched and created by Gottfried Wilhelm Leibniz. But before him, the binary system has existed for a long time. It was first introduced in China in one of the oldest Chinese texts dating back to the 9th century BCE. The Book of Changes or Classic Changes is where the binary system was first introduced. This book talks about the concept of yin-yang. In the book, yin-yang is represented through trigrams and later versions of the book in hexagrams. Leibniz saw the characters/trigrams used in the concept of yin-yang and discovered it resembles a system with two combinations. A solid line for 1 and a line split in half for 0. Leibniz researched and created the binary system using this. This led him to writing the paper L'explication de l'arithmétique binaire. Even though Leibniz's system was inspired by the Book of Changes, he was the one who formulated the binary system that is used to this day. Some of you watching this video might think, hey, what does this have to do with math? Well, I have no idea. Well, the binary system is made up of powers. Here we have 1010 in binary, which equals to 10 in our decimal system. So 0 would be the first bit, which would be 2 to the power of 0. Next will be 2 to the power of 1, then 2 to the power of 2, then 2 to the power of 3, and so on. The product of these powers become 1, 2, 4, and 8.
We can convert this to a decimal number with this information. We take the bits, then multiply those with the product of the power, and then add those together.
So 0 times 1 plus 1 times 2 plus 0 times 4 plus 1 times 8 is the final expression, which equals 10. Alright, this needs to be quick, like really quick. Like, how much time is left? A binary sequence can equal to a bunch of different things, like letters of the alphabet, numbers, or shade of color. Pretty nice. Another thing that's on my mind is, if computer can only read binary, then what is this stuff? This coding language is what developers use to tell a machine what to do while still vaguely understanding the language. This language enters a translator, which gets turned into binary, which the computer can read, though it's not as easy as I thought it would be. Believe me, I've tried. Thank you all for watching. I hope you enjoyed the video. And I was wondering to myself during the creation of this video, like, why did Leibniz choose 1 and 0 or not 2 and 5? After animating this whole video and editing it, let's just say I'm very tired. So I'll leave that to you to figure out.